And so let's take a look at how we can graph systems of linear inequalities. Now these are similar in one way to systems of equations in the sense that we're trying to find out the values of x and y that are going to make both equations true at the same time. But now in order to solve a system of inequalities, we're basically trying to find all of the ordered pairs that are going to make both of these statements true. And really the best way and only way really to solve these inequalities or solve these systems of inequalities is by graphing both inequalities and then shading. So let's start off by just graphing the first inequality. We're going to subtract x from both sides to put it in slope-intercept form, and now graph. The y-intercept here is 6, so we're going to plot our y-intercept at 6. And now the slope is -1, so we're going to rise -1 and run 1. Or we're going to rise 1 and go left 1. Notice that because it says greater than, we're simply going to be putting a dashed line. Now we normally would shade above the line because it says y is greater than, but it's important to recognize that instead we don't want to make our graph look messy with a lot of different shading since we're going to be graphing multiple inequalities at the same time. So instead, just put arrows in the direction that you will eventually be shading. Let's now graph the inequality x minus y is less than or equal to 2. Here we can subtract x, and when we subtract x, we still have to divide by -y. Now remember, dividing by a -1 will flip this inequality sign to a greater than or equal, and therefore it'll change both of these signs on the right side as well. Well, now our y-intercept is -2, and our slope, or coefficient of x, is 1, or rather 1 over 1. So rise 1, run 1. And notice that when we graph our solid line, because it says it's a greater than or equal to, the equal to indicates that it's solid, we're now going to be shading above the line, greater than the line. Well, again, keep in mind that this is a hill, and we're going to be shading above the hill. So again, we put our arrows to indicate the direction. Now these are the only two inequalities in this problem that we're going to graph, so we're now ready to shade. So we're going to shade where both of the arrows are intersecting, and so we can see that it's above this green line and above this red line, which is why the intersection is up in this region here. And any point that lies in this region is considered the solution or a solution to this system of inequalities. Let's look at one with a few more inequalities to see what this would look like. We're still doing the same thing, but we're going to be graphing and shading only at the very end. In the meantime, we're going to be putting arrows to indicate the direction we will eventually shade. So let's start with the first equation. We see that the first inequality has a y-intercept of -3. And now the slope is a rise of 3 and a run of 4. So we're going to rise 3 and run 4. Rise 3, run 4. Now it says only greater than, so we know that that's going to be a dashed line. And it says greater than, not equal to, and therefore we're going to be shading above the line. Now let's take a look at the green inequality. The green inequality has a y-intercept of +4, and now we can see that it's going to go down to left 1, or down to right 1. And so with a slope of -2, we see that it's going to be a negative slope going down to right 1, down to right 1. And because it says less than or equal, we're going to be graphing a solid line. And now again, picture this as a hill. Somebody standing on the hill would have to shade below the line because we're shading less than. So already if we were to stop here, we should be able to see that the intersection is this region over on the left side, because that's where all the green arrows and red arrows are pointing together. But we're not done, because we still have to graph y is greater than or equal to -3. Well, remember that -3, y equals -3 is going to be the horizontal line, and since it's greater than or equal to -3, we're graphing all the y values that are above this line. So now it's cut this region off to where it's everything above the blue line above the red line and below the green. But we've got one last line to graph, which is x is greater than -2. So we now go to -2 on the x-axis and draw our vertical line. But to graph greater than, we first of all graph the dashed line, and we're going to be picking all the x values that are bigger than -2, which is why we're shading to the right of that line. We've now graphed all 4 inequalities neatly on the same graph. We're now ready to shade. So we're going to shade the region where all of the arrows are pointing together, which is just this region here. Now this region is indicating that any point that lies in this graph is going to be a solution to all 4 inequalities. If we were to pick 0, 0, 0, 0 would work in all of these inequalities, but so would the point -1, 4. And so would this point -1.5 and -2.2. Wherever these points happen to be would all work in all inequalities. So when graphing systems of inequalities, to keep it a little neater so that we're not shading over shades, is to put arrows to indicate the direction before we shade the final result.